Dear learners, greetings. I am Professor Sajid Jamal from the Department of Education, your course coordinator, and today I am going to deliver a lecture on the topic types and levels of data. So in this whole session, first we try to understand what is data and how data, information and knowledge, all these three are related with each other. Then we will see how many types of data are there, types of data based on general classification, types of data based on levels, of course, and then there are four types of scales about which we will discuss in this whole session. So first let me explain what data is. So if you see, data is a plural word and its singular form is datum, and it is a Latin word, and datum means something given. So the term data refers to groups of information that represents the qualitative or quantitative attributes of a variable or set of variables, and of course it is the lowest level of abstraction from which information and knowledge is derived. So let me tell it to you. Data means height of Mount Everest is 8848 meters. So this is the lowest level of abstraction. From somewhere I came to know about this thing, or I have gone through some books, or I was viewing some internet resources, and from that I have got that the height of the Mount Everest is 8848 meter. So it is data. Now I am taking some more information. I mean, if you will reach at such a height, so what will be the climate, and what will be the pressure over there, and definitely snow will be there or not, I mean something like that. So that comes under the category of information. And when I meet someone, or further I go to some books or something like that, and I find some more details, so that comes under the category of knowledge. So remember, this is the pyramid, data lowest level and knowledge highest level. And definitely there will be so many data, so much data. We will process that data. After processing the data, we get some information, and after getting more and more information, finally we come to conclusion. So somehow this is the relationship among data, information and knowledge. And coming to the second point that has been mentioned on the slide, data is also a representation of a fact, figure or sometimes idea also. So how many types of data are there? So based on general classification, we will come to the conclusion that data are of four types: raw data, metadata or ancillary data, experimental data, and fourth one is the field data. So let me explain all these one by one. So raw data, which is unprocessed. For example, you have taken as a teacher, you have taken a test of your 50 students and their marks from 0 to suppose 90. So this is raw data. I mean unprocessed, unclassified, untabulated, So it might be some number, it might be some characters, it might be some images. So simply unprocessed and unorganized data is known as raw data. So what we do next, we process this raw data to get other type of data. And what are those other type of data? Metadata or ancillary data. So what it contains, it is a description of raw data. For example, I have given library catalogs. So details are there on the library catalog. If you see there is one catalog, and in this written title of the book, the author of the book, what has been described in that particular book, from where that book has been published, the year of publication. I mean, so many things are there. But definitely such type of data are known as metadata or ancillary data, because they have been derived from the raw data. So unless and until you will have raw data, you will not have metadata or ancillary data. Then comes experimental data. So what is experimental data? The data which is obtained by observation or recording of scientific investigation. So we are engaged in so many scientific investigation, or we are engaged in so many scientific experiments. So whatever the data at that time we get, that comes under the category of experimental data. Similarly, we have field data. And what is field data? Which is the data which is collected, which is obtained in real life situation, in real time situation. So I want to know the achievement of students in science. Suppose they are class 10th students, and I want to know their achievement in science particularly. So what I will do, I will take some sample. For example, I have taken the sample of 500 students. These 500 students have been selected, suppose, from 10 schools. So I will go to those institutions, those schools, and there I will administer that science achievement test, and after that I will score, and then I will get the data, and I will be coming to some conclusion what is their performance. I mean, further I will do tabulation, classification and organization and all those things. So such type of data which we get the moment we go to the field is known as field data. Another example might be, I want to know, suppose I am a sales executive, so my company makes so many detergents, so suppose 10 detergents. So which detergent is liked most by the consumers? So I will go to the town and to the villages, and I will collect the data, I will take the information, I will ask them which detergent you like most, and definitely on the basis of that I will be coming to some conclusions. So such data which is obtained the moment we go to the field, that data is known as field data. So on the basis of general classification, you can say that data are of 4 types: raw data, ancillary data or metadata, experimental data, and field data. But there is another classification also of data, and that is based on measurement. So remember, in the previous slide, types of data was based on general classification, but in this slide, types of data is based on measurement. And types of data based on measurement, we have 2 types of data: continuous data and discrete data. So what is continuous data? I mean, which we can express up to so many places of decimal, which is capable of any degree of subdivision depending on the precision of measurement. For example, you have a weighing machine, and that weighing machine is not very sophisticated, is not digitalized, you can say, and it measures only up to 1 place of decimal. So someone stands up on that machine and then it tells 40.5 kg. So it is telling 40.5 kg weight simply because it has the precision of only 1 place of decimal. But there is another machine which is more sophisticated, more digitalized. So it is measuring it up to 2 places of decimal, and it is saying that it is 40.49. Even some more digitalized machine might be there, some more precise machine might be there, and it is telling that your weight is 40.488 kg. So weight is such type of measurement which we may express up to as many places of decimals as we want, or up to as many places of decimals as our machine or our tool of measurement is able to measure. But contrary, I mean, besides weight, you can express height also, you can express temperature also, you can express voltage also. So there are so many attributes which might be measured up to so many places of decimals. But besides it, there are so many things which we can't measure in decimal. For example, number of boys and girls. Number of boys and girls. So in my class there are 31 boys and 19 girls. So they will be 31 boys and 19 girls. It is not possible for me to say that there are 30.5 boys or 31.5 boys and 19.5 girls or 18.5 girls. No. So such some of the things definitely they can be expressed only in whole numbers, and it's difficult for us to express those in the decimal. So on the basis of measurement, by and large, we have these two data, continuous data and of course discrete data. Now one thing that is very important is levels of data, and particularly in the field of sociology, in the field of psychology, in the field of education, or in the field of by and large social sciences, these levels of data matter. And what are these levels of data? There are 4 levels of data: nominal, ordinal, interval and ratio. So I am going to talk on these data one by one. So first let me talk about nominal data. So nominal data is that data which is conducted by nominal scale. Now the question arises, what is nominal scale? So you see the slide, it is the most lowest level of measurement. It entails classifying data without regard to numerical value or order. So for example, I have taken 2 type of sample, male and female. So somehow I am coding males as 1, females as 2. So it never means that male are better than the female. No, just I have categorized. I mean, I might do reverse also. I might say female 1 and male 2. So just my purpose is differentiation between 2 groups. So such type of scale is known as nominal scale. Let me give you another example. You have seen football players, and if you see their jersey, so someone's number is 13. Someone's number is 1. Someone's number is 98. So it doesn't mean that the player whose jersey bears the number 1 is the best player and the player whose jersey bears the number 98 is the worst one. No, not like that. In fact, just we want to differentiate. We have 3 players. One player is having the number 1 and the player is having the number 13. Third player may be having the number 19, someone might have number 55, someone might have number 91, someone might have number 22 or someone might have number 34, like that. So our purpose is just to differentiate one individual from the other. So our purpose is labeling, and in this labeling numbers are only used for the categorization purpose, for the classification purpose as well as for the identification purpose. And members of one group might may not be, there might, the equivalence relationship that is there is reflexive, transitive and symmetrical, and applicable calculations are percentage, frequency, proportion, mode and coefficient of contingency. So let me give you one example. An example is like this. I am a sales executive in some company, and my company makes fairness cream. So my company makes 5 fairness creams. So I want to know, as a sales executive, which product is liked by most of my consumers. So I will just all the 5 creams, I will give number 1, 2, 3, 4 and 5. So to some cream I have given 1 number, to some cream I have given 2 number, to some cream I have given 3 number, to some cream I have given 4 number, and to some cream I have given 5 number. So 1, 2, 3, 4, 5 here are not given in the order of any merit. Just purpose is labeling, just purpose is differentiation. And then I went to collect the data, and suppose I have conducted the data from 250 people, and out of 250 people, 220 people are preferring cream number 5. It means what? That cream number 5 is the most popular cream that is produced by my company. So here what I will do, just I will be using mode, and mode is a very good in fact tool the moment we collect the data on the basis of the nominal scale. So remember, repeatedly I am saying, our purpose is just identification, our purpose is just categorization, our purpose is just classification, and for that what we do, we calculate percentages, sometimes we calculate frequency, sometimes we calculate proportion, and sometimes we calculate coefficient of contingency. So these are the best calculations the moment data has been collected on the nominal scale. But there is another scale which is more you can say which is different from nominal scale, and that is what? Ordinal scale. So let me explain. What is ordinal scale? Ranks that you get. So rank 1, 2 and 3. So how rank has been obtained? So there is one particular student who has scored 98% mark, and accordingly he has been given rank 1. By scoring 98% mark, he has got rank 1. There is another student who has scored 97.5% mark, he has scored rank 2. But there is another student who has scored 73% mark, and he has got rank 3. So see, the difference in the rank, that is 1, 2 and 3 is same, but the difference in the percentage is not same, you know. So the difference between first rank and second rank is just 0.5%, but the difference between second rank and third rank is much more in comparison to the difference between first rank and second rank. So this type of scale is known as ordinal scale. So what a ordinal scale does, the ordinal scale arranges data in ordered categories showing the rank or order of items, but the difference between ranks are not equal, which just I have explained through the example that is shown on the slide. Then it indicates order but not the magnitude of difference between ranks of the individual, and there is no absolute zero. This is the you can say characteristic of ordinal scale. There is no absolute zero. So in the coming two scales we will be talking about this point further in detail. What's the meaning of absolute zero? So in this ordinal scale, numbers are used to denote the rank from highest to lowest. Here greater than the lesser than relationship exists, which is asymmetrical, which is irreflexible, but it is transitive. And if you have collected some data on the basis of ordinal scale, so which calculation you will do in this situation? As in the previous case when I was discussing nominal scale, I told you people that mode will be the best way. Here in the ordinal case, in the ordinal scale, the moment you have collected the data on ordinal scale, median will be most appropriate, percentiles will be very good, rank correlation will be very good, particularly at the moment we have collected the data on ordinal scale. So some examples you can see. Socioeconomic status of some people. So low, middle and higher. But how much difference is there between lower and middle class, and is not necessarily the same as the difference between middle and higher level. So socioeconomic status comes under the category of ordinal scale. Educational level, I mean, someone has got only primary education, someone has got secondary education, someone has got tertiary education. Again, it is a level, it is based on ordinal scale, and rank in some competition that I have explained. So nominal scale and ordinal scale, let me tell you the difference. Nominal scale's purpose is just identification, just classification, just differentiation. Ordinal scale is in some ways better than nominal scale, but here the problem is that we don't have the absolute zero, or we don't have the same difference between successive ranks. The third scale that we frequently use is interval scale. And what is this interval scale? Suppose I am collecting some data and I have fixed 5 categories in that data: strongly agree, agree, undecided, disagree, and strongly disagree. So suppose I want to know the attitude of my students towards internal evaluation, toward internal assessment. So I have framed 30 questions, 30 items, and the student or the respondents are required to put a tick mark on any of these 5. I mean, they might put a tick mark on a strongly agree category, they might put a tick mark on agree category, they might put a tick mark on undecided category. If they disagree, then definitely they can put a tick mark on disagree category, and if they feel strongly disagree against some item, so they may put a tick mark on a strongly disagree category. So I might score like this. I have given 5 score to strongly agree category, 4 to agree category, 3 to undecided category, 2 to disagree category, and 1 to strongly disagree category. So this is up to me, because what my purpose is just to measure on how many items they have strongly agree opinion, and how many agree and undecided or something like that. So suppose it is a 30 item scale. So at the end I will find the sum, and finally I will tell the score, and on the basis of that score I will say whether they have a positive or favorable attitude towards internal evaluation, or they have negative or unfavorable attitude towards internal evaluation. So it is not necessary that I am putting this scheme. I may put like this. I may give 4 to strongly agree, 3 to agree, 2 to undecided, 1 to disagree, and 0 to strongly disagree. Again, no problem. I will collect their opinion on all the 30 items, and finally I will be putting some score, and I will be finding the sum, and that sum will in total tell me whether they have positive or favorable attitude or not. Even I may go to some other marking scheme as well. For example, I am saying strongly agree 3, agree 2, undecided 1, disagree 0, and strongly disagree -1. Or I can say strongly agree 2, agree 1, undecided 0, disagree -1, and strongly disagree -2. So again there will be no problem. I mean, I will be collecting the opinion on all the 30 item, and I will be putting the score, then I will be calculating the total, I will be finding the total, and finally that will be from that score I will be able to know whether the students have in general a favorable or unfavorable attitude towards internal evaluation. So this type of scale is known as interval scale. Why this is an interval scale? Because you will find the difference, successive difference between the interval is same. So the difference between 5 and 4 is same as the difference between 4 and 3, and as the difference between 3 and 2, and as the difference between 2 and 1. Similarly here, if you see, again the difference you will find the same. So in interval scale, basically what happens, you will find the difference between successive intervals is same. So it gives equal numerical differences, I mean that I have explained. So whatever the trait we are measuring, there will be the equal difference in magnitude of the properties being measured. But there is no absolute zero, and through these examples you can see how our zero is shifting. So in this case 0 was here, but in this case 0 was here. So in interval scale, the successive differences between two interval is same, but we don't have the absolute zero. And the perfect example is the temperature scale in Celsius or Fahrenheit. So this is the perfect example how an interval scale is there. Definitely in Celsius scale or Fahrenheit scale, there is no absolute zero. So if you come and if you talk about behavioral sciences, so IQ scores are such scores which come under the category of interval scale, because here again you will not get the absolute zero. So interval scale is such a scale which has lot of merits, lot of advantages are there for the interval scale, but only thing is that it does not have absolute zero. And if you talk about which calculations are very suitable for interval scale, so I have mentioned if you have collected the data on the interval scale, so you use mean. So in the previous two cases, when you have collected the data on nominal scale, it will be better to use mode. The moment you have collected the data on ordinal scale, ordinal level data you have, so use median. But if you have collected the data on interval scale, it will be better to use mean. And similarly, standard deviation, Pearson's coefficient of correlation. And what is Pearson's coefficient of correlation? You will be taught later on. T-test, F-test, I mean so many tests you might use if you are using the interval scale. And so far as our behavioral sciences are concerned, I mean sociology, psychology, education and these type of subjects, so most frequently used scale that we have is the interval scale. So with this, let's proceed to another scale, and that is ratio scale. So what is ratio scale? It is the highest level of measurement. It is the most precise measurement as well. So nominal, ordinal, interval and ratio. So move, this is the highest level of measurement and this is the lowest level. This is the lowest level and this is the highest level. This is highest level of measurement, ratio scale. And most important feature of the ratio scale is that the two numbers of the ratio are independent measures of a particular unit and meaningful equation can be done. So most important characteristic of ratio scale is it includes 0 point, that is 0 is fixed. And since 0 is fixed, that's why it allows for meaningful ratio comparisons. This is not there so far as the previous three scales are concerned, the previous three scales which have been talked before you. So it allows for all mathematical operations. I mean, you can go for addition, you can go for subtraction, you can go for multiplication, and you can go for division whenever it is needed. And it includes coefficient of variation also. But if you talk about ratio scale, you will find that mostly it happens in physical science. Particularly if you want to measure height, if you want to measure weight, if you want to measure age, income, distance, I mean all these things, so you will find that the ratio scale is there. So in a nutshell, if you see, nominal, ordinal, interval and ratio scale I have mentioned, and I have mentioned that nominal scale is the lowest level of measurement, whereas the highest measurement is ratio scale, and out of all these four scales, ratio scale is the only scale which has a fixed a 0. So I think that's sufficient for today. I have recommended some books that you can see the slide. All these books are very good. So if you want to know something more about the scales, about the levels of data, definitely you can go through these books. So for today it's enough. I will come with some other topic. So please take care and have a good day. Thank you.